From our quiet corner of the cosmos, the universe looks peaceful, a silent tapestry of distant lights. But this serenity is an illusion, a veil of distance hiding a reality of unimaginable power. The cosmos is a stage for both breathtaking creation and unimaginable violence. The calm we perceive is deceptive, a realm where worlds are born and annihilated in the blink of a cosmic eye. Stars are born in fiery nurseries and die in cataclysmic supernova explosions, briefly outshining entire galaxies while forging the heavy elements that make planets, and even us, possible. Unseen forces like the immense gravity of black holes shape the very fabric of space-time, bending light and time itself in a cosmic dance we are only just beginning to understand. Amidst this chaos, Earth is a fragile lifeboat. We are adrift in a dangerous sea, protected only by a thin atmosphere and an invisible magnetic shield against constant cosmic radiation. Yet we are not immune. Powerful solar storms can lash our planet, threatening our technology, while the immense heat from our planet's core fuels the volcanic and seismic forces that reshape our world from below. These are not abstract concepts. A single asteroid impact can alter the course of life on Earth forever, proving our vulnerability in an instant. In the next 10 minutes, we will journey to witness these forces firsthand. We'll tour the most powerful and destructive events nature can unleash, from hypernovas to colliding neutron stars. We'll witness energies that release more power in a second than our sun will in its entire lifetime. This is a story of fire and pressure, but also one of cosmic creation, where destruction sows the seeds for new worlds. Prepare to see the universe's most dramatic performances. Guided by the latest science, we'll explore the physics behind these epic events and reveal their profound connection to our own existence. Let's begin our journey. The next 10 minutes will change how you see the universe and your place within it. The cosmic show is about to start. Our journey begins at the heart of our solar system, the Sun. For billions of years, its steady light has nurtured life on Earth, making it the ultimate source of our existence. But this life-giving star has a violent, unpredictable side, a capacity for destruction on a planetary scale. Its surface is a churning sea of superheated gas, roiled by powerful magnetic forces. Because the Sun rotates faster at its equator than at its poles, these magnetic field lines become twisted and tangled, storing up unimaginable energy. When they reach a breaking point, they snap and realign, unleashing that energy in a blinding flash. This is a solar flare, a cataclysmic explosion releasing the energy of millions of hydrogen bombs. Often accompanying these flares are coronal mass ejections, or CMEs. These are colossal bubbles of magnetized plasma, billions of tons of solar material hurled into space at millions of miles per hour. If one is aimed at Earth, it becomes a cosmic bullet. Our planet's first line of defense is the magnetosphere, an invisible shield that deflects the solar wind. But a direct hit from a powerful CME can overwhelm this shield. The immediate result can be breathtakingly beautiful, dazzling auroras, but the unseen effects are far more sinister. In 1859, humanity got a taste of this fury. English astronomer Richard Carrington witnessed a brilliant flare on the Sun. Just 18 hours later, the fastest CME ever recorded slammed into Earth. The resulting geomagnetic storm, the Carrington event, wreaked havoc. Telegraph systems worldwide went haywire, shocking operators and setting paper on fire. Auroras were so bright that people could read newspapers by their light, and they were seen as far south as Cuba. If a storm of that magnitude struck today, the consequences would be catastrophic. The initial surge would cripple power grids, destroying irreplaceable transformers and plunging continents into darkness for months, or even years. Our satellites, essential for GPS, weather forecasting, and global communications, would be fried, the internet would collapse, the cost would be measured in the trillions, the impact on society incalculable. Our modern world is far more vulnerable than the telegraph-based society of the 19th century. The Sun, our life-giver, could send us back to a pre-industrial age in minutes. Scientists warn it's not a question of if, but when. Are we ready? While we often look to the skies for threats, one of the most profound dangers lies dormant, deep beneath our feet. We're not talking about ordinary volcanoes, but a force with planetary consequences. Supervolcanoes. Unlike classic cone-shaped mountains, a supervolcano doesn't build upwards. It forms over a vast underground chamber of magma, accumulating immense pressure. When it erupts, it detonates with unimaginable force, leaving behind not a peak but a massive crater called a caldera. At the heart of Yellowstone National Park lies one of the world's most dangerous. Its famous geysers and hot springs are the beautiful but ominous surface expressions of this power, fueled by a massive simmering magma chamber just miles beneath the surface. Yellowstone has erupted 3 times in the last 2 million years, each with world-changing force. The last event, 640,000 years ago, was 1,000 times more powerful than Mount St. Helens, burying states in ash and creating the park's vast caldera. If it erupted today, the blast would devastate everything for miles. The true catastrophe would be the ash, blanketing North America. It would collapse buildings, poison water, and ruin crops. Power grids would fail, and transportation would grind to a halt. The impact would quickly go global. Ash and sulfur in the atmosphere would block sunlight, triggering a volcanic winter. Global temperatures would plummet, leading to worldwide famine and chaos. A Yellowstone eruption would be a civilization-altering event. The ground beneath us holds power beyond our control. While an eruption isn't imminent, Yellowstone is a constant reminder that we live on a volatile world, a fact we must never forget. From slow-building pressure to instant fury, lightning. A single bolt is hotter than the sun's surface, carrying billions of joules in a split second. Lightning forms as storm clouds churn, building up static electricity until the air can't hold it back. The result, a blinding flash that neutralizes the charge. Beyond cloud-to-ground strikes, there are sprites, elves, and blue jets. Mysterious flashes high above storms. These phenomena remind us that even familiar storms hold secrets. Lightning isn't unique to Earth. Jupiter, Saturn, Mars, and Venus all have their own electrical storms. Wherever there's an atmosphere and turbulence, lightning follows. It's one of the universe's most dazzling, universal displays of raw energy. Every flash is a reminder of nature's power. Even the ordinary can be extraordinary. For millennia, only nature wielded cosmic power until we split the atom. Nuclear fission unlocked the energy of the stars, giving us nuclear power and the atomic bomb. A bomb's chain reaction releases energy in a millionth of a second, rivaling nature's fury. Hiroshima was the first demonstration a single bomb vaporized a city. Since then, weapons have grown thousands of times more powerful. The Tsar Bomba dwarfed even supervolcanoes in destructive force. A full-scale nuclear war could trigger a nuclear winter, collapsing ecosystems and civilization. We created a force of nature, one we may never fully control. Our self-made star is both a triumph and a warning. The power to destroy is now in human hands. Even our mightiest weapons pale beside a supernova, the explosive death of a massive star. When a star's fuel runs out, gravity crushes its core, triggering a shockwave that tears the star apart. For weeks, a supernova can outshine an entire galaxy. But this destruction is also creation. The universe began with hydrogen and helium. Supernovae forge heavier elements: carbon, oxygen, iron, gold. These elements seed new stars, planets, and life. We are literally made of stardust, born from ancient explosions. Every atom in our bodies was forged in a dying star. Supernovae are not distant curiosities. They are our cosmic ancestors. The cycle of stellar death and rebirth shapes everything we know. Look at your hand. You're holding the ashes of a supernova. The universe's violence is the source of our existence. We are children of the stars. After a supernova, the core may become a neutron star, one of the universe's strangest objects. Imagine the sun's mass squeezed into a sphere the size of a city. A teaspoon of neutron star matter weighs 1 billion tons. These stars spin rapidly, with magnetic fields trillions of times stronger than Earth's. Their beams of radiation sweep across space. If they point at us, we see pulses, pulsars. When first discovered, their regularity was so precise, some thought they were alien signals. Pulsars radiate immense energy, gradually slowing over millions of years. The Crab pulsar spins 30 times a second, lighting up its nebula. These cosmic lighthouses are the ticking clocks of dead stars. Their steady pulse is a heartbeat from beyond the grave. Sometimes a neutron star becomes something even stranger, a magnetar. Magnetars have magnetic fields 1,000,000,000,000 times stronger than Earth's, the most intense in the universe. Their fields twist and crack the star's crust, causing starquakes. These quakes unleash bursts of gamma rays and X-rays, outshining the sun's output in a fraction of a second. In 2004, a magnetar flare 50,000 light-years away disrupted Earth's atmosphere. If one erupted nearby, it could strip away our ozone and trigger mass extinction. Magnetars push physics to its limits. Their fields would tear atoms apart from 1,000 miles away. They are the universe's true magnetic monsters. Each discovery reveals something more powerful and mysterious. The cosmos always has another surprise. Magnetars remind us the universe's extremes are beyond imagination. We've witnessed the sun's fury, Earth's hidden power, and the violence of dying stars. Each event is a story of energy destruction and creation. The night sky's calm hides a universe in constant violent change. Yet these forces are also engines of creation. Supervolcanoes bring new mineral supernovae, forge life's elements. Death and rebirth are the universe's rhythm. We exist because stars died. Our role: we are the universe's witnesses, able to look back and understand. Science lets us measure, model, and comprehend these epic events. This knowledge brings humility and wonder. We are small, but our minds can grasp the cosmos. We are the universe's way of knowing itself. In seeking knowledge, we find our connection to the stars. The universe lives in us as we live in it.